Hello everyone, welcome to the INS practical series. In this session, we'll be doing the IP security configuration. So, we'll be doing this practical in some steps. So, the first step would be the implementing the topology using Cisco Packet Tracer. We'll use a topology and then we'll configure the IP addresses and set the IP route. Then second step would be to configure the host name on all the routers R0, R1, R2, and then we'll enable the security package at R1 and R2, and then see that we'll ping a message from one PC to other, and we'll see that it fails actually. And in step 3, we'll apply ACL access control list at router 1 and router 2 and set the IPsec MP policy and IPsec MP key and set IPsec transform set. And then in the fourth step, we will create the crypto map and apply the crypto map at the required interfaces, and finally verify the output by pinging one PC from the other one, and we'll see that ping will be successful in this case. Then this is the required topology. We'll be implementing this particular topology. So what we are going to do in this particular case is that we won't be setting any routing path in this case. Okay? So this router only knows about this network and this network, and this router only knows about this one and this one, and the third router, this one, only knows about this and this. So in the absence of any routing path, suppose if we send a message from this PC to this one, if we ping, the ping will fail because we have not set the routing path. This network, this router knows about this network and this, but has no information about this one and this one. So in the absence of routing path, this will actually drop the packet. But what we are going to do is we will set a VPN, virtual private network, using this IPsec protocol. So in that case, when any packet which is forwarded from this to this, it goes through this path actually. Okay, and but this is a virtual path. We can assume that the packet will not actually travel from here, it will travel from this path only. But this IPsec, it creates a tunnel. It would appear to us that it is going from this path to this path. Okay, and this router will not know the actual destination. Okay, so this is what we are going to do using in this particular session. And these are some of the parameters we'll be setting by IPsec MP policy parameters. So the key distribution methods which are available, it is manual and IPsec MP, and we'll be using in R1 and R2 we'll be using the IPsec MP. And encryption algorithms, various algorithms are available. We'll be using AES256, and hash algorithm, MD5 and hash SHA are available. We'll be using SHA in both the cases. And authentication methods, we can use a pre-shared key or RSA. In this case, we'll be using a pre-shared key. Then the key exchange is Diffie-Hellman group 125. We'll be using group 5. And ISE SA lifetime, so it can be 86,400 seconds or less, so we'll be using this 86,400. And the IPsec MP key is user defined, so we'll be using iSmile as the key in both the cases. Okay. And then these are the IPsec parameters. So transform set key is VPN set, and ESP transformed information encryption is ESP AES, and then authentication is ESP SHA HMAC. The peer IP addresses, as we can see here, this is mentioned, okay, in both the cases. Then the traffic is from R1 to R2, and from here R2 to R1. And this crypto map name is IPsec map, and SA establishment is this one. So we'll be using this particular data for configuring. Okay, so now let us start with the Cisco Packet Tracer and configure and do the configuration. So before starting with the configuration, we must actually first see this particular topology. Okay, so here what we have is we can see there's a PC here. That we got two PCs. The IP address of PCs, as you can see, these are mentioned address 192.168.1.2, and then we have a router at this point. Okay, this is the router. This has two interfaces. One is G00 up, IP address is 20.0.0.1, and the other interface is G01. This is the IP address. Then the R0 router is this one, the middle one. The G01 interface is connected at this end and 00 at this end, and these are the IP addresses. And the router number 2, 00 is connected up and 01 is connected down. Okay. And this is a switch, and the last we have this is the PC. So before starting with the configuration, you must actually draw this diagram somewhere, and take care while actually configuring the router. G00 is 20.0.1 and G01 is, so we should take care about that interfaces and the IP. Now let us configure it now. Now we would configure the IP addresses. So start with the leftmost PC0. So here we go to desktop. This IP address is 192.168.1.2. This is 192.168.1.1. Okay. Similarly, we do the configuration for all the other interfaces. Now next part would be to set the IP route. So for this particular router, that is router 1, we have to set the path through 20.0.0.2, and for router 2, that is this path would be through 30.0.0.2. So let us see how we do this in Cisco Packet Tracer. So I just click on this router and we click on CLI mode, and in CLI mode maybe we may get some default prompt like I am getting here. As you can see, this is router. Okay, so I will just enable command. Okay, and then because some commands work in some prompts, so we need to go in that particular global configuration mode. So for that I type this configure terminal, and here we type the command IP route. Okay, space 0.0.0.0 space 0.0.0.0, and for this router the path would be 20.0.0.2. okay, so this is set. I'll just close this and then go to router 2. In router 2 we click on CLI mode, and here also we get the same thing. So I'll just enter and then enable and then configure terminal, and here also IP root, and then the 0.0.0.0, then 0.0.0.0, and here we have this 30.0.0.2. okay, so this is set. Okay, now what we'll do, we'll try to ping this PC to this PC. We'll type a ping message. Let us see whether we are able to ping or not. Of course the ping will fail, so just click on command prompt and ping to the rightmost PC. The IP address is 192.168.2.2. now this ping should fail. okay, so we are getting a request timeout. okay, if you try it again, you'll get the same thing. okay, now let us try from this to the rightmost PC, ping, and the IP address 192.168.1.2. okay, now this ping fails because we have not set the IP route from that particular router. okay, so here the trouble is this router only knows about these two networks, and this only knows about these two networks. So this particular router has no information about this particular route and this particular route, so therefore the ping would fail, of course. Now we'll see how we can use IPsec protocol to send a packet without actually setting the IP route, and how we can actually tunnel this packet. It will reach here, and without this particular router knowing the final destination. We'll do this by IPsec protocol. Now the next thing we do is assign the host name to each router. I just click on this particular router, go in CLI mode. okay, we'll get this. So enable and then configure terminal, and you can type your host name. So I'll give the host name as R0. Now you can see the name, we get this host name as R0. Now we'll do the same thing in the other routers. So let us come to this router 1. So CLI mode, so enable and then configure terminal, and then give the host name. We give the host name as R1. okay, this is the host name R1. okay, then we assign the host name to router 2. okay, same thing, enable, configure terminal, sorry, okay, configure terminal is done. okay, then next is host name. So host name is R2. we're done. okay. Now the next part we have to do is we have to enable the security package on router R1 and router R2. First of all, let us check whether the security version is enabled or not. I'll just click on this router. okay, and then this, we need to actually how to check this. So we have to exit from this prompt, and now I will type the command show version. Now when we type the command show version, we get this information. I'll just show the security package was enabled or not. As you can see, security packet is not enabled, so we need to enable the security package. So we again go into the global configuration mode, configure terminal. Okay, now here we need to enable that. So what we do is type the command license boot, okay, module C1900 technology package and security K9. So it will ask us enable, accept or no. We'll just write yes. Okay, so this is done. Okay, so we have done this. Now we exit from here and type the command copy run to startup configuration. Yes. Okay, now we reload this. We reload this router. Okay, you should just confirm. It will reload. After it gets reloaded, we can actually check again show version, and we'll see that it will be enabled. Okay, so now we need to enable this first, enable the router, then here itself we can check show version. Now it will show that that package is actually enabled. So you can see this security is actually enabled. Now we do the same thing in the second router. Now let us configure the access control list on router 1 and router 2. First let us start on router 1. So we are on router 1 now. So first we need to enable it, and then configure terminal. Now we type the access control list. Number is 100, and we want to permit the IP. All the IP packets having the network addresses 192.168.1.0, and the wildcard mask is 0.0.0.255, and the destination network is 192.168.2.0, and this is the wildcard mask. Okay, this is done. Now next we will have to implement the policy ICKMP. So type the command crypto IPSec and policy. We define the policy as 10 number 10. And then encryption, what encryption we'll be using is AES 256. Okay. And then authentication, which we'll be using is pre-share. And then group, that is the Diffie-Hellman group, is 5. And we exit now. Next we need to set up the IPsec key. So type the command crypto IPsec and the key, we'll be using the key iSmile, and the address, the destination address where we have to will send in this packet. So it is 30.0.0.1. okay. This is not the IP address of this router, but the second one which will be receiving the packets. Okay. Then next command crypto IPsec transform set. Now this transform set is from R1 to R2. So we write in this way, and ESP AES, then space 256, this is the size of the key, then ESP hyphen SHA secure hash algorithm, and HMAC, which is used for message authentication. So this is done on router 1. Now we'll do the same thing on router 2. Next we create the IPsec map 10 on both the routers. First we access router 1. So we click on this router 1 and type the command crypto map. We name this map as IPsec, all in capital letters. Sorry. So this IPsec dash map 10 IPsec IPsec MP. So it is configured. Next is set PFS, set peer. This is the address of the destination router, interface of that. Then we will set PFS group 5. Now there is no space between group and 5. Then next is set security association. And we need to give the lifetime in seconds, so we set up the maximum times 86400. Then we set the transform set from R1 to R2. Next, the match address is 100. There is a number of our access control list. Match address is 100. Now we need to apply this, whatever we have made this mapping, to the proper interface. So we need to access interface. So interface G00. We need to type this command, interface G00. This we have to get this command, apply this map. So crypto map, and that our map was IPsec, capital IPsec dash map. Now this we have done on router 1. Now we'll do on router 2. You can see this is on. Let us apply this on router 2. The same thing will apply on router 2 also. Now we verify the working of IPsec using this VPN tunnel by just pinging PC1 from PC0. So I will just click on PC0 first, and in command prompt yes, we got the output now. As you can see, we are getting the output. First time it failed. I tried it first time, so we'll get it after 2-3 minutes. After we configure, we'll get this output after 2-3 minutes. Okay, and we can check it back here again. So command prompt, and so here we are, we got the output. So that's how this particular protocol works. Okay, in the first time we'll get all the failures. We have to wait for some time and then again ping again, maybe 2-3 minutes after we'll get the output. So that's all for this particular session. Thanks for watching.